Okay, here we go. 2.3, solving linear inequalities. And a bit background information. Let's make sure that we're clear on a few things. First, 7 is less than 10. We all would agree with that. And I'm going to go ahead and do what I did in the last lesson. I'm going to go ahead and add an amount to both sides of this inequality. So let me just draw a line here. I'm going to add 2. Now, if I add 2, I end up with a statement of 9. I have 11, and 9 is still less than 11, so we're good there. So let's go ahead and change that up. Now let's go ahead and subtract an amount from each side here. So we'll say subtract, say 4. All right, subtract 4. And so now I end up with something that says like 5 is less than 7. Still, once again, very true. So let's go ahead and try something else. Let's go ahead and multiply by, say, I don't know, say 10. Okay, times 10. And 5 times 10, 50. 7 times 10, 70. And we have 50 is less than 70. Still also very true. Okay. Well, let's go ahead and maybe divide by something. Let's divide by 5. Okay. And now we end up with 50 divided by 10 and 70 divided by 5 ends up being 14, and you get 10 is less than 14. Also very true. All right, well, I'm going to go ahead and bring that over here. 10 is less than 14 is where we left off. Now, this just shows that we can add an amount, subtract an amount, multiply an amount, and divide an amount. And our inequality sign just keeps falling down. Okay, well, now I'm going to do something we haven't done, which is multiply by a negative amount. So let's go ahead and multiply by, say, negative 2. Okay. When I multiply by negative 2, I'm going to put it in parentheses because of the negative. I end up with a statement that says negative 20 is, and, well, you know what, let's do this first. Negative 28. Negative 20, if I bring that sign down, it would say less than negative 28, and that's not really true. Negative 20 is actually bigger than negative 28 because negative 20 is closer to 0. Think of it on a number line here. Here's 0. Here's the positive end. Here's negative 20. And here would be like negative 28 if you kind of think of it that way. Obviously not to scale. So that means that negative 20 is bigger. That means this sign right here had to switch directions. Okay, so multiplying by a negative, we know we have to switch that sign over. Let's go ahead and try, what happens if I divide by a negative? So, you know what, let's go ahead and divide them both by, let's say, negative 4. Okay. And when I do that, a negative divided by negative is a positive, I get 5. And a negative divided by negative is a positive, I get 7. So I now have 5 is greater than 7 if I keep that sign. It wouldn't be true. I have to switch it around again. That sign has to switch over again. Okay? And so dividing by a negative also means I need to switch signs or flip the sign, however you want to say that. Maybe you say flip the sign. Depends the terminology, but you switch the sign over. Okay, if it was greater than, it becomes less than. It was less than, it becomes greater than. So that's kind of a rule. When multiplying or dividing by a negative, the inequality sign changes directions. Okay, kind of a key to this lesson. All right, so let's go ahead and try some problems here. I have 7q, 7 times q is less than or equal to 35. So really I'm just solving like a normal equation. I divide both sides by 7. I did not divide by a negative, so nothing happens other than I just drop the symbol down and I have 5. Graphing, same type of graphing, 0, 5, solid, because it includes 5 as part of my solution. 5 is equal to 5, and everything less than 5 is on the left. Or if I test 0, 0 is less than 5, so I have to shade over 0, all the negatives as well. Or the other way to remember, think about it, since the variable's on the left in your inequality, the arrow will always point in the direction you're going to shade, as long as your variable comes first, is on the left. Okay, so notice I didn't switch my signs, just like right here when I multiplied by a positive, I didn't have to switch the sign over. It stayed exactly the same. Okay, well, here, I'm sorry, I guess that wasn't when I was multiplying by the positive. It was when I was dividing by a positive. Right here, I didn't have to switch the sign. The next one's going to be multiplying by a positive. Okay, so on this one, we've got to multiply by 2. And since it's multiplying by a positive, 2 of those is equal to 1. 2 of 1/2 n's is 1 n. So they were dividing by 2, we multiplied by 2. And negative 15 times 2 is negative 30. Now don't be confused. It was already negative. The number you brought over to the other side to multiply by was positive. So you didn't multiply by a negative. The value was already negative. So you don't switch your sign over. You leave it the same. Okay? So n is greater than or equal to negative 30. And so we've got our 0. We have our negative 30. We have greater than or equal to, meaning solid, because it includes that value. Negative 30 is a solution to this. Negative 30 is equal to negative 30. And everything bigger, like 0. 0 is greater than negative 30. All right. Let's go ahead and try another one. Here. All right. I'm going to go ahead and divide by a negative 4. Now remember, dividing by a negative. When I multiply or divide by a negative, my sign has to switch over. So I'm left with y. I get negative 5 was positive. It becomes negative. We divided by a negative. That switches my sign. Okay. And so this time, y is greater than negative 5. There's 0. There's negative 5. Open circle. And I'm going to go ahead and shade to the right because 0 is bigger than negative 5. It does not include negative 5. Negative 5 is not a solution here. Negative 5 is not greater than negative 5. Since we don't have the equal to part, we have to have an open circle. Okay. Here we're going to multiply by negative 3. They're dividing by negative 3. Multiply by negative 3. I'll put it in parentheses there. It doesn't look like we're subtracting. Negative times negative is positive. Multiplying by negative 3 and divided by negative 3 cancels out. Then 12 times negative 3, negative 36. That switches that sign around. Okay, we multiplied by a negative, meaning that sign had to change. It was less than, it's now greater than. Okay? There's our 0. We have negative 36. It's an open circle because it does not include 36. And 0 is bigger than negative 36. We shade over 0. Oops, got to put the 6 there. Last one's a fraction here. I am going to multiply by a negative. Okay, and really, the way you get rid of a fraction when multiplying is to multiply by the reciprocal, which is just flipping that over. So for those of you who have forgotten that, reciprocal just means you flip the fraction over. Okay, if you had like 3/7 or 2/4, or you know what, let's just give an example here. 3/5, the reciprocal of that is 5/3. Okay, and what happens when you multiply by the reciprocal? The values cancel. 7 cross cancels with 7. 3 cross cancels with 3. Negative times negative is positive, so I'm left with a positive x, which is what you want. Then you multiply by negative 7/3 here. Well, multiplying by that negative flips that sign over. So it was greater than, it's now less than. 7's cancel. Okay. Positive times negative is negative. 8 times, that's a 1. Now because the 7 canceled is 8. And this is a 1. 1 times 3 is 3. I have negative 8/3. If you want, you could change that. That would be negative 3 goes into 8 twice, which gives you 6/3. So you'll have 2/3 left over. Negative 2 and 2/3. It may just help you to think about where it is on a number line. I'm fine if you just list negative 8/3 or negative 2 2/3, either one. They're both the same value. Either list it like that and put your open circle and shade to the left because it's pointing left. Some of your teachers may want you to actually list negative 2 and then like negative 3 and have those values on the number line and then the fractional piece in between. That's kind of up to your teacher. So there we got it. All right. That's it. Good luck.